Have you ever caught yourself watching a sci-fi movie and thinking, man, when is all this mind-bending tech actually going to get here? Well, I've got a secret for you. That future you're waiting for, it's literally running right now, probably sitting right there on your desk. Today, we're diving into this explainer to uncover everything you need to know about the emerging tech that's already in our hands. We'll look inside your computer at the secrets of AI, holograms, and next-gen ports. So let's jump right in and decode this rapidly changing world. I mean, seriously, just look around. We've got cars navigating busy city streets entirely on their own, and 3D printers that are literally building complex objects from the ground up. Today's technology isn't just changing the way we live, it's accelerating at absolutely mind-blowing speeds. We're not just waiting for the next big leap anymore, We're actively living right inside of it. But to really wrap our heads around what's happening, we first need to pin down what we mean by emerging technology. Sure, it generally describes something completely new, but it can also be a massive, radical advancement of something we already have, right? We aren't just talking about, say, getting a slightly faster phone. We are talking about giant developments that create sweeping technical, institutional, and social changes. It's the kind of stuff that shifts how our entire society functions from the ground up. So how do we spot these game changers in the wild? Well, you want to look for four main things. First, pure innovation. Second, incredibly fast growth. Third, consistency over time. And fourth, a prominent impact. I'm talking about the kind of impact that completely shakes up industries and creates entirely new headaches like brand new copyright and patent challenges. And guys, this is the reality of emerging tech right now. Take artificial intelligence, for example. The whole goal there is to build systems that act and think just like us. It's wild. And when you pair that with robotics, which is this incredible mashup of computer science and mechanical engineering, you are completely revolutionizing how we manufacture, operate, and use machines. The power is literally right in our hands. Now, when it comes to how we actually perceive these digital spaces, we basically have two diverging paths. First, virtual reality. VR pulls you completely into 100% artificial 3D sensory environment. It's heavily used right now in medical and manufacturing fields. But conversely, we have augmented reality, or AR. AR integrates directly with our real-world environment. It overlays computer-generated content right onto your actual physical surroundings. It's like having a digital layer over real life. Okay, here's a fun one. You've probably heard the word a million times, but did you know the origin of the word hologram actually comes from Greek? Yep. Holos means whole, and gramma means message. Unlike standard 3D imaging, which kind of just fakes depth on a flat 2D screen, a true hologram is a three-dimensional, freestanding image created with photographic projection. It is literally a whole message projected right into thin air. How cool is that?
Okay, moving on to section 1, the engine. CPU versus GPU. Let's look under the hood.
Think of this as an epic showdown of processing philosophies. On one side, we have the CPU, the central processing unit. The CPU has a few very strong processing cores, and it is perfectly suited for serial workloads, basically doing complex tasks one right after the other. On the flip side, we have the GPU, the graphics processing unit. The GPU takes the complete opposite approach. It uses thousands of weaker cores that all work together at the exact same time. That makes it an absolute powerhouse for massive parallel workloads. And because of this completely different architecture, a CPU needs super quick access to your system's main RAM to juggle all its high-level tasks. The GPU, however, is crunching so much simultaneous data. I mean, we're talking about rendering intense 3D worlds or processing massive AI algorithms, that it actually relies on its own dedicated ultra-fast memory, known as VRAM. It's a totally different beast. Up next is Section 2, ports, connecting the power. Let's talk about how we actually hook all this stuff up. So a port is basically our physical bridge for information to flow in and out. And honestly, nothing tells the story of our accelerating tech quite like the evolution of the Universal Serial Bus, better known as USB. Get this, back in 1998, USB version 1.1 gave us data rates of just 12 megabits per second. Fast forward to 2013, and USB version 3.1, also known as SuperSpeed Plus, was rocketing data at 10 gigabits per second. That is an astronomical leap in speed, not to mention the massive upgrades we got in power delivery. And all of that evolution led us directly to this absolute game changer right here, the Type-C port. This is the latest design, packing 24 pins, and it can handle a seriously robust current for fast charging your devices. But let's be real, the absolute best feature, the thing we all secretly love the most, is that it has no up or down. You never have to blindly flip your connector over 3 times just to plug it in anymore. It delivers incredible speed, video, and power protocols all in one beautifully reversible shape. But beyond USB, your computer relies on a few other essential physical bridges to do its job. There's HDMI, the high-definition media interface, which transfers video signals at massive resolutions up to 4K. Then we've got SATA ports, which use high-speed serial cables to talk to your storage devices like hard drives. And for the absolute fastest components inside your machine, we use PCIe, or Peripheral Component Interconnect Express. That's the ultra-fast slot you use for high-speed expansion cards.
Which brings us to Section 3, Peripherals, controlling your world.
Now, you might not traditionally think of a massive graphic card as a peripheral, but it absolutely is. It's a highly advanced output device. This expansion card is primarily designed to take the heavy graphical processing tasks completely off your main CPU. By utilizing its own dedicated GPU and VRAM, it processes and executes all those advanced graphical techniques to actually generate the high-quality visuals you see on your monitor. Without this peripheral, those beautiful VR worlds and 3D spaces we talked about earlier, they just remain completely invisible data. On the input side, we use devices so effortlessly every single day that we completely forget their underlying complexity. Think about the humble computer mouse. It is seamlessly translating highly specific physical intents, like hovering over links, dragging and dropping files, scrolling long documents, and doing complex combination keystrokes into digital reality in real time. It's essentially the physical interface that bends the digital environment to your exact will. Pretty amazing when you stop and think about it. So when you step back and look at the whole picture, the artificial intelligence, the true holograms, the massive parallel processors, and those blazing fast ports, it is so clear that the technology of tomorrow is already hard at work inside our machines today. So I'm going to leave you with this question. Which of these emerging technologies are you most excited to see evolve next? Take a minute to think about it, and make sure you join us for our next explainer as we continue to unpack the incredible, constantly changing world of tech. Until then, keep exploring.